R.K Medicos once again. In this section, we are going to discuss about the physiology, and this is the third part of our physiology. In this, we are going to discuss how the any molecules are crossing the membrane, and what membrane? The any cell membrane or the any membranes of our different parts of the body in which the different cells are located, and what the boundaries of these cells through which these molecules are passes. Then what does it mean? What is the membrane transport? How the molecules are get transported from one part of the membrane to the other side of the membrane? It means, suppose that we are going to see here about the general physiology. It means we are going to discuss about the now general physiology. It means generally how the physiology is working, in which the part third now. Previously we discussed already part 1 and part 2. Next we are going to discuss the membrane transport, in which the any molecule, suppose that this is the our any cell. Inside the cell, what happen? The some molecules are present outside the cell, and these molecules wants to be travel inside the cells. So we have to cross these barriers. What is the barrier? Barrier is here cell membrane. What the boundaries of this cell are called as the cell membrane, and these are basically made up of the phospholipids or the bilayer of the phospholipid bilayers. These are the membranes we have to cross, and there's a different way of crossing these membranes, and that's why there is a transport. There's a different types of transport mechanism are working here, and we are going to see one by one how these transports are happen, and what are the different types of transport, what are the classification of these transports. And these all transports are through the membranes. That's why this topic name is what? Membrane transport. We are going to discuss here what? Membrane, because this is the membrane and through which these molecules are going to enter from outside of the cell to the inside of the cell. That's why they are called as the basically membrane transport. What is the introductory part of this topic? We can see here the classification of membrane transport is basically based upon the energy dependent or energy independent. What does it mean? The any molecule, suppose that this is the cell, this is the molecules. These molecules wants to be travel inside these cells, and they requires energy or not. First point, either they may be, we can also say like that, we can also say the any molecules which wants to travel inside these cells, they may be requires energy, or they may not be requires energy. When these molecules are require energy for their transport, that's why they are called as the active transport. And what the molecules are moving inside the cells, they does not require any type of energy. These cells are called as what? Passive transport. These two simple terms. When the energy is required, energy is in the form of ATP. When the ATP is required, these are called as active transport, and ATP is not required, it is called as passive transport. These are the two simple terms, ATP required and ATP not required. After that we can see what does it mean required or not required. The required of ATP is called as active, good, and no need of ATP is called as passive, good. Then we are going to see now one by one what is the active transport and what is the passive transport in a detailed way. First we are taking here the passive transport. What are the passive transport? They do not need any type of energy for their transport. They do not need any type of energy source for their transport of these substances from outside of the cell to the inside of the cell. That does not require any type of energy. They are the passive transport. They are basically three main types. We can see here what are the three main types of the passive transport. Basically the diffusion and the simple one. Next one is facilitated diffusion. Once again, there are two types of diffusion. One is simple, they are simply crossing the membrane according to the concentration gradient, and other one is facilitated. They can be facilitated, they can be helped by the different types of mechanism are working here in the facilitated diffusion. There may be some tunnels are built inside these membranes. Some tunnels are like the protein channels are made for their transport from the outside to inside the cell. So they are facilitated by something. That's why they're the facilitated diffusion. We can see later how they're working and what are the tunnels or the channels are called as. First we are going to see what are the three main types of the passive transport. The first one is simple diffusion, and the third one we can see osmosis. Simple osmosis. What does it mean? The transport of something liquid substance, we can see later what are the different three types of the passive transport we see now. After that we are going to see one by one what is the simple diffusion is it. The simple diffusion is any substances which are crossing from higher concentration to the lower concentration. Suppose that this is the any cell and there is a high concentration of some substances are present here. Suppose that the sodium amount will be higher here, and inside the cell there is a 5 sodium outside the cell and the 2 sodium inside the cell. This sodium wants to be enter inside the cell, but sodium transporter are the active transport. Suppose that the something, so we can't take sodium as example. We can take substance A is in higher quantity outside and same substance A is lower quantity in B. It means inside the cell. We can see the substances which are start moving from higher concentration to lower concentration, and the barrier is what? Membrane. Then this diffusion, these molecules entering from outside to inside the cell diffuses are called as simple when they are moving from higher concentration to lower concentration. Same as we can see inside our lungs, we can see here, suppose that this is our lungs. What happened? This is the trachea through which the air is entering in the bronchi. These air are coming. These air are in the, suppose that this is our bronchi, after that alveoli. These airs are enters inside it. Suppose that this is the blood capillaries. In the blood capillaries there is a less amount of oxygen and there is a higher amount of oxygen is where? In the bronchi or the alveoli, and the blood capillaries or in the blood vessels there is a lesser amount of O2 and there is the higher amount of O2. So the O2 is start getting to diffuse from higher concentration to lower concentration, and here CO2 is higher in amount. Then CO2 is moving where? From lower concentration, and CO2 is where? Lower in the bronchi. So in the bronchi the CO2 amount will be lower. So this what is happening here, this CO2 amount is higher in the blood capillaries. We can make a clear picture here. We can see after that. Look at here. Suppose that this is the lung. This is any blood capillary. Here is the O2 is less and CO2 is higher mainly, and in the lungs O2 is more and CO2 is less. So you can tell me what is the O2 concentration is where? Higher in the lungs, which means the O2 is start diffusing from higher concentration to lower concentration, and they balancing the O2 concentration. After that what happened? The CO2 concentration low is where? In the lungs. It means where is higher? In the blood vessels. They start moving towards the lungs. This is the type of diffusion, and it is basically simple diffusion. In the lungs what type of diffusion is happened? Simple diffusion. They just start concentration moving from higher to lower. We can see a term that is called as Fick's law. What is Fick's law? Is basically the diffusion is directly proportional to the concentration of that concentration gradient of that area. What are the concentration is present in that specific area? When the area is increasing, the diffusion is increasing. We can see like this. Suppose that this is the cell surface where the molecules are gets diffused. When their area will be more, the more molecules will be diffused. It is true. And when suppose that these membranes are get thickened, suppose that initially these membranes thickness will be 1 millimeter. They gets easily diffused. The molecules are easily gets diffused and enters inside the cell. What happened later on? The thickness of these membrane are increased up to 5 times. They may be 5 millimeter. What happened after that? These molecules are can't penetrating. These gases element, maybe O2 and CO2 are can't penetrate these membranes. So the less amount of oxygen or CO2 will be passes through it. So it will be inversely proportional. When the any membrane will be increases in thickness, it will be leads to less diffusion. The surface area will be more. They are the less thickness. It means they are the more increase in diffusion. The more surface area, more diffuse. Less surface area, less diffusion. More thickness in the membrane, less diffusion. It is the Fick's law. Next point we can see what is the diffusion relationship with solubility. What does it mean, solubility? Basically, suppose that our membrane is a composition of what? Lipids. Suppose that these molecules are lipid soluble. They are going to bind with lipid and easily they get transported from outside to inside. When the lipid solubility substances are more in number, there is a more diffusion. It is true. The lipid soluble molecules are diffusion more in the lipids. Their lipid membranes are lipid made up of lipid. That's why their solubility is more and they enters inside the cell more. Suppose that these pores of these membranes are fixed 0.3 micrometer. Suppose that after these molecules are, suppose that some molecules are starting to enter inside the cells and their shape or sizes will be increases up to 5 micrometer or the 3 micrometer. So it can't be penetrated with these membranes, which can't be penetrated with these holes. So these molecules, when the molecule size will be increases, there is a decrease in diffusion. When the molecule size will be decreases, there will be less, they are passing more easily. How we can see the lipid soluble molecule will be more easily transported in the diffusion way. It means more lipid soluble, more diffused. More lipid solubility of the any molecules, more passing through the membrane. And the sizes will be increases, the less will be the diffusion. So this is all about the relationship with them. After that we can see the second part, that is the facilitated diffusion. In facilitated diffusion I can tell you already, I told you, these are the carrier transportation through which there is a facilitation is done. It means something is gets facilitated by something. We can see here there is a carrier proteins are present. Carrier proteins, it means suppose that this is our membrane and there is a special type of carrier proteins. Suppose that this is the carrier proteins. This is the CP. Carrier proteins are present here through which these molecules, suppose that this is the molecule, this molecule is passes inside the cell. So there is a special type of carrier protein is needed for their passing from the outside of the cell to the inside of cell. So these molecules are passing through the special carrier protein. That's why they are called as facilitated diffusion. These carrier proteins are facilitating these transports, but these transports do not require any type of energy. That's why they are the passive or active. They are the passive transport. So what type of the diffusion proteins or the carrier proteins are called as this different types of facilitated diffusion? The facilitated diffusion is done by what type of receptors or the channels? We can see here there are the two different types. Basically we can see first glucose transport and water transport. Glucose transport in the any cell, suppose that this is the cell and here is the one receptor is present. Through these receptors the glucose molecule is binding to it and then transported inside the cell. Then these receptors are called as GLUT receptor, and this is the special type of carrier mediated protein. Once again there is a one here channel is present through which the water is enters inside it, and these water channels are called as aqua. Aqua means water, porins means pore like a structure. The aqua porins. The two different types of transports that is facilitated, they are coming under the facilitated diffusion, that is glucose transporter and water transporter. Glucose transporter is called as GLUT and the water transporters are called as aquaporins. So these two examples are related under the facilitated diffusion. Next point we are going to see here about the osmosis. Osmosis is simple. There is a transfer of sodium. They require sodium or H2O always follow the water. As we listen from the childhood, the water follow the sodium. Suppose that the water is moving in this direction, sodium is also following it. Or we can see the sodium is going in this way, water following this. Why? Because the sodium is the main key role in the transportation of water. When the sodium is moving anywhere, the water is also going through the same side. We can see here the sodium is osmotically active substance. It means they are providing osmotically active, they are providing the solids will be highly active in that case, and they express in the milliosmol. This is the unit which in which we are going to osmotically active substances gets be measured, and they are gets expressed in this way of milliosmol. The milliosmol we can also write like this, MOSM. These are the milliosmol is gets expressed what we are going to osmotically active substance will be measured in it. So this is the simple unit how we can measure it. And osmosis is simple, the transportation of water through the any membrane. What is the we are going to here discuss about the some definition, osmolarity and osmolality. What is the osmolarity means and what is the osmolality means? Osmolality is what it is the first we are going to see osmolarity is the milliosmol of what? Osmotically active substance. Osmotically active substance, simple. Osmolarity is the milliosmol of osmotically active substance. When the any osmotically active substance, their milliosmol unit is called as the osmolarity. Suppose that the sodium here in the any solute in per liter, in a 1 liter of the any solution, there is a what amount of the solute should be present in osmotically active phases. These are called as the osmolarity. And the most commonly used in the normal plasma osmolarity in the any human body cells, the normal plasma concentration osmolarity will be the 280 to 300 milliosmol per liter. When we are going to measuring it, the osmolarity in our normal plasma, then it will come to 80 to 300 milliosmol per liter. After it we can see osmolality. It is the milliosmol of solute. Above one is the osmotically active substance which is present in the per liter, and here is the milliosmol solute in the per kg. This unit is most important here. This is measured in liter and this is measured in kg of the solvent. It means the kg is calculated. How the milliosmol is calculated? How the osmolality is calculated here? The osmolality is calculated by the any amount of sodium. The value of sodium will be putted here. They multiplied with 2. And the glucose amount will be put here. The value of glucose is multiplied with 0.05. After that, BUN, the blood urea nitrogen level should be mentioned here. That these all three comes together is added. They giving the sum of osmolality. The osmolality is measured in the 2 into multiply of the sodium plus 0.05 into the glucose plus 0.36 into the BUN, blood urea nitrogen concentration. This formula can be used as a calculation of the osmolality. This is all about the definition. Not we are going to discuss about the very deep in the definition or the formulas. We are now going to discuss about the active transport here. The passive transport is basically 3. You know now. There is a simple diffusion, facilitated diffusion, and the osmosis. After that we can see active transport. How the active transport is working? Active transport is simply means the required energy, the required ATP. It means the requires energy in the form of what? ATP. It's simple. The active transport is basically divided on the basis of the required of energy. There are 2 types. There is a primary active transport or the secondary active transport. These are the 2 active type of transport, primary and secondary. Simple. What are the names of primary active transport and what are the names of, it means example, what are the names of the secondary active transport? The primary active transport names are most important or the more important here. Sodium potassium antipage pump. These are the primary active transport. Calcium plus 2 antipage are the primary active transport, or the hydrogen antipage, or we can also say like this, there is a proton pump, calcium pump, or the calcium antipages, or the sodium potassium antipages. There is a 3 antipages: sodium potassium antipage, calcium antipage, and the proton antipage, or they are also called a hydrogen antipage. Next we can see what are the secondary active transport. They are the 2 in number basically. Co-transporters. Co-transporters means they are we can say like this. Suppose that this is the membrane of any cells. They can transport the molecules in a same way, in the same direction, and they helping to each other. They helping to each other in the same way. They are called as co. Co means helpful. They are the helping to each other. Co-transportation. You can say like this. In detail we can discuss later, but for now we are going to discuss about the just example. There, what are the primary active transport? 3: sodium, potassium, calcium, and the hydrogen. Secondary one is the co-transporter and exchangers. What are the name of exchangers? We discuss later. For now, you have to memorize 2. Co-transporter and exchangers are the secondary active transport. Now we are going to discuss one by one. In the primary active transport, we can see first one is sodium potassium antipage pump, and in the sodium potassium antipage pump is basically present in the membrane of any cell. Suppose that this is the membrane, we can see this is the membrane, and this is, suppose that this is the outer part of membrane, this is the inner part of membrane. It means we can see from the outside and we can see from the inside. What happened to the outside? Suppose that this is the transmembrane protein, TMP, transmembrane protein. What happened? These are present everywhere in our body. These transmembrane proteins or the sodium potassium antipage pumps are present everywhere in our body. They expressed whole body in the whole region. That's why they are called as universal pump or the universal expression. We can see here these are the example of transmembrane protein. First point, they are situated inside the cell membrane or the membrane. That's why they are the transmembrane, and they are present all in the all body cells. That's why they are called as universal expression of these channels or the universal activation of these pumps. And the ubiquitous, it means that they are universally situated all over the body. There are having 2 subunits of these channels, sodium and potassium antipase. That's why they are in the dimer form. 2 subunits. One means monomer or the mono, and the second one is the dimer. 2 subunits means dimer form, and both these subunits are in different manner. Both these subunits are situated in the different manner, means their location or their shape and size will be supported different. That's why they are called as heteromer, or they are also called as heterodimer. Why dimer? There are two subunits and their structures will be different, and that's why they are called as the heterodimer. It is true. The sodium and potassium antipage pump is a heterodimer pump. It is true. It is a transmembrane protein. It is true. It is the universally situated everywhere in the body. It is true. It is having 2 subunits. It is true. We can see here what are the 2 subunits. There is a alpha subunit and beta subunits, and there is extracellular compartment, intracellular compartment. We can see also the alpha unit is responsible for the sodium and beta unit is responsible for the potassium. There is 2 subunits. The alpha subunit is responsible for the regulation of sodium ions, and the potassium ion is regulated by the beta subunits of the sodium potassium antipase pump. After that, we can see what are the function of these pumps. We can see the exchange of sodium and potassium, as we discussed above, or the sodium is transported by the alpha or beta, alpha subunit, and the potassium with the beta subunits. Next point, we can say the 3 sodium is regulated, is moving out. From now we can see here there is a 3 sodium plus is situated here. These sodium are moving here, 3. These sodiums are moving out and potassium are moving in. The 2 potassium are coming in from here, from the beta. 2 potassium are coming in. This is the main role of the sodium potassium pump. They maintaining the basically electron potential inside these cells. They maintaining the electropositivity or the electronegativity inside the cells, electropositivity outside the cells. We can see here 2 potassium ions come inside the cells. Till now everything is clear. Next point, we can see these both are doing in somehow they are sending the molecules outside and inside. They are working in a couple like manner. They are working in a opposite way. They are working in a same coordination. That's why they are called as the that's why they are called as the coupling. Coupling, it means the ratio of coupling will be the sodium is going 3 in number out, but the potassium is coming 2 in number in. It means inside the coupling ratio, their movement ratio or the coupling ratio is 3:2, because the written here 3 means sodium is going 3 out and 2 potassium is in. The most important subunit of sodium potassium is alpha, and alpha is binding what? Alpha subunit is binding sodium, and it is the most important site here. They are binding the sodium ions and they are transporting the outside the cell. And the we can see the potassium binding and digoxin binding site is present on the alpha subunit and the extracellular portion. What does it mean? Suppose that in this picture, this alpha subunit and this is their extracellular part, and the intracellular part of alpha subunit is here. So this is the intracellular and this is the extracellular. The intracellular structure of alpha subunit is most important in this channel. The intracellular part of the alpha subunit, this is the alpha subunit, is the most important for the several bindings, and the alpha subunit extracellular part is the most important for the several bindings. And what are their bindings? The extracellular portion of the alpha subunit is binding something, means outside the alpha subunit is binding something, and this is the potassium and digoxin binding, and something is inside the binding. Inside the binding of the alpha subunit is intracellular portion, that is the sodium and ATP. The sodium and ATP binding inside the intracellular part of the alpha portion of the which part? Sodium potassium Antipage pump. And what is the outside portion? It is binding the two structure, potassium and digoxin. Digoxin is the drug, basically they are the antiarrhythmic drug. They are used in the patient is having arrhythmia or the tachycardia, or the we can say like this, there is a paroxysmal tachycardia, like this type of disease we can use digoxin. That their binding site be present in the outside of the cell. The cellular activity will be done. So these are the two activities we can see here. The sodium and the ATP binding is present in intracellular compartment of the alpha subunit, and the alpha subunit is having extracellular compartment is binding to a structure. That one is the potassium and digoxin. Next part we can see what is the secondary active transport. This is basically the usually two or more substances are transported. In the secondary transport, we are going to transport two or more than two substances is transported here. These are transported happen in same direction either or in the either opposite direction. When the any molecules are going to be, we can say like this. Suppose that this is the membrane, and the any molecules are moving, two or more means two or more molecules are moving in the same direction, then they are called as the co-transporter, or they are also called as symporters. Sim in same side, that is symporters. Suppose that they are moving in opposite direction, in this, that they are moving in opposite direction, both. They are moving in this and this, opposite direction in both. They are called as the antiport. Anti means opposite, or porter means transport, antiporter. And they are also called as exchanger. Why they are called as exchanger? Because they are exchanging both the sides. In this side something, this side something. They both sides they are exchanging in opposite way. They are exchanging. When the exchanges happen in between two persons, it means something is given by you and something is taken by you. That is the exchange. It means the exchangers are antiporters. Same side are the transporters or co-transporters. They are called as the symporters or co-transporters. So we can understand what are the channels are co-transporters, what are the anti-transporters. We can see the names of several. We have to memorize it, name of them. The first we can see here about the exchangers or antiporters. There is a chloride and carbonate exchangers. Next point we can see they are present mainly in the RBCs. Next, co-transporter or the symporters, we can see sodium and glucose transporters are the co-transporter. They are moving same side, same. Next one is sodium potassium 2 chloride co-transporter. They are present in our nephron and they are helping in the transporting the sodium potassium 2 chloride ions in the nephron. We are discussing in the renal section. Next, third part, sodium iodide symporters, co-transporters or the symporter. The sodium glucose, sodium potassium 2 chloride symporters or the co-transporters, and the last one is sodium iodide transporters. and in the antipode section we are going to discuss about the chloride carbonate exchangers. So these are the several examples of the co-transporters and anti-transporters. We have to memorize it because they are the most important, and we discuss further in the different sections about these transporters, how they're working and where are they located in our different parts of body. Now we are going to see first one, sodium glucose transporter. This is also known as SGLT, sodium glucose link transporter. These are the basically two types, SGLT1 and SGLT2. Sodium glucose link transporters first is present in our intestine part, and the second one is present in our kidney part. And in present mainly kidney, there is a PCT part where the PCT is located. We can see, suppose that this is the nephron, this and this. This is our glomeruli. This is our PCT. In PCT section, SPGLT1 or 2. In SPGLT2 section is present. SPGLT2, SGLT. SGLT2 is located here in the PCT section. This one is loop of Henle, this is the DCT, and this one is collecting duct. So now we have to know this PCT section is containing SGLT. We can see next point. Formation, there is function as ORS is explained by this. What does it mean? The SGLT is basically working in the which region? Intestine. What happened in this intestine region? These are the channels are the working sodium glucose co-transporter. They basically in the ORS what we take on, basically the sodium and electrolytes will be present inside it. Electrolytes is basically sodium and chloride. We can see these sodium are transported along with glucose. The sodiums are the transporting glucose also. When these sodiums are moving from our intestine region to our blood vessels or the blood circulation, they are moving through the glucose. They are providing energy also. These are the co-transporters are helpful in the transporting the energy with electrolytes. Next we can see sodium potassium 2 chloride co-transporters. They are basically present in the loop of Henle of our nephron, of kidney, and we can see just previously we are seeing like this. In this section, basically in this section it is present sodium potassium 2 chloride symporters or co-transporters. This is the channel which is located in the loop of Henle, basically in the descending or ascending. There is ascending or descending loop of Henle. They are situated loop of Henle in this region. They are helpful in the transportation of sodium, potassium, and the 2 chloride symporters are situated here. And primarily we discuss here PCT in what is the located. There is a location of sodium glucose transporter. There are two types, SGLT1 in intestine and SGLT2 in PCT. You can see here. Next one we are going to see in this section, that is sodium and potassium glucose transporter. We can see this is also called as Barter channel. The Barter channel is also another name of it. Sodium potassium 2 chloride symporters or co-transporters. These are located where? In the loop of Henle of the nephron of kidney. These channels are also called as Barter channels, but in there any mutation of these channels, when there is these symporters or the co-transporters are get mutated, the person is develop a special type of symptoms or the syndromes. That one is called as Barter syndrome. We discuss later what happened in these patients, but for now we have to memorize it. Barter syndrome is developed after the patient is having the mutation in the Barter channel, and Barter channel is basically what? It is the sodium potassium 2 chloride symporters or the co-transporters. When the patient is having any lesion to this region, we are going to block them, because this is the co-transporters. Suppose that in our nephron region, here these molecules are present, sodium potassium or the chloride, they are going to moving inside the blood volume or the plasma. Suppose that they are in the very less amount, so we are going to block this. And for the blocking, when the any blocking in this region, in pharmacology section we are going to discuss, when we are going to blocking the any in the loop region, it means loop of Henle region, these drugs are called as loop diuretics. These drugs are called as what? Loop diuretics. The loop diuretics are the drug which are going to blocking the loop of Henle region of the nephron of kidney, and the special drug is memorizing here, that is furosemide is a loop diuretics. One other is spironolactone. So these are the drugs, they are the loop diuretics, they are blocking them. Next one we are going to see, third one. We discuss later everything. So which drug is most important in it? There is a patient is having, we are going to blocking the diuretics, or for the diuretics in the loop region, that is the furosemide or spironolactone. Next point we can see, third channel, sodium iodide symptoter. Third channel, they are present in the thyroid gland. For now you have to memorize it. Memorize only this one, that is thyroid. Inside the thyroid gland, sodium iodide symptoters are present. They are regulating the iodide level from maintaining iodide in the intestinal blood circulation. They absorbing it and moving inside the thyroid gland. After that they are making the different types of activity doing by them. We are discussing in the thyroid gland section in our endocrine part. Next, third point, we are going to discuss vesicular. Some different type of transport, or the special type of transport is the vesicular transport. Vesicular transport is the special type of transport in which the transportation is happen in the vesicles form. How? Suppose that this is the cell and this is the one bag. Bag is called as vesicles. Something is moving from outside to inside. This vesicle movement from outside to inside is called as vesicular transport. Or maybe this transportation is also happen from inside to outside. So these are also called as the vesicular transport. These are the vesicular transport is basically happen in the bag or the container. They are in the vesicles like form, and this is the active type of transport. This is a what type of transport? Active transport. They requires calcium for the release. Suppose that we are going to see like this, these molecules are moving like this from there and till the membrane, they are coming like this. In the membrane they are going to, these channels are these bags are going to do like this, and they fuse with the membrane. Suppose that this is the bag, they are moving like this, and suppose that this is the cell. This wait for a second, this is the vesicles, they're moving near to the membrane, and after that what happened, this is forming a fusion with membrane like this, and this is gets opened and their content will be released here. Suppose that this is the bag inside the cell, they are going to near to the membrane and they're fusing to them, and after that they release their content outside. The releasing of their content outside is called as exocytosis process, and from their releasing the content, the calcium ions are responsible for the releasing, because they are the contractile. They are activating the contractile proteins, and these contractile proteins are helpful in the contraction of these cells and the releasing their content outside of these cells. There is a special type of element is required, that one is calcium, and there is a special proteins are present for the working. They are what are the vesicular transports, and there are special proteins we are going to discuss now. Okay, we can see here a special protein. Suppose that when the molecules are, suppose that this is the cell, any molecules are moving from inside the cells to outside through this their opening of these cells content. This process is called as exocytosis, the movement from outside to inside. Suppose that some molecules are moving inside the cell, and the movement inside the cell is by the three way basically. In this process is called as endocytosis. When the any molecules moving outside to inside the cells in the vesicles form endocytosis outside, that's exocytosis. The endocytosis is happened with 3 proteins. Endocytosis is done by the 3 proteins, means any content wants to move from outside to inside in the vesicles form. The 3 proteins are leading the main activity here. Clathrin, we can call like this CMC, Christian Medical College, or you can see like this CMC, that is the clathrin, megalin, cubilin. Clathrin, megalin, cubilin are the 3 proteins which are participate in the movement of endocytosis. They are participate in the vesicular transport. What type of vesicular transport? They are moving into the endocytosis type of vesicular transport is done by the 3 different types of proteins, that is CMC, clathrin, megalin and cubilin. We can see next one, exocytosis. The movement from outside to inside is done by the snare protein. We can see the releasing of neurotransmitters is also done by through this proteins. Snare proteins is helpful in the movement of neurotransmitter. Neurotransmitter is coming from the nerve terminals. Basically this is our nerve terminals through which these neurotransmitters are released, and they are done by the exocytosis. And there is a which type of protein is working? Snare protein. In next point we are going to discuss about one by one exocytosis and endocytosis, how they are working. We can see here the exocytosis is a vesicles moving out, simple. When the vesicles are moving out from the cell, exocytosis, simple. If the any substance each gets stored in our cell and they gets processed, storing and processing is happen inside the cells, and after that they are gets packing in the vesicles, and the stimulus is providing to them. To triggering the stimulus, they are moving out, they are moving towards the membrane, and after that they are releasing their content outside. What happened? They are regulated by the exocytosis, and this type of movement is called as non-constitutive exocytosis. This type of movement, what type of movement? Substance stored and processing is happened, after that they are packing in vesicles and the stimulus is triggering them and they are releasing their content, that is called as non-constitutive exocytosis. What happening next? If the substance is not stored, they gets not stored and processed, they directly released, they are called as constitutive exocytosis. There is no vesicles are present, they directly exocytosis is happened. Suppose that this is the cell, inside the cell these vesicles are filled with some substances, they wants to release it, and they moving, there's some substances are stored, they are gets packed in the vesicles. They are called constitutive or non-constitutive? Non-constitutive exocytosis. But what happened when these content are without storing anywhere, they directly release out, they are called as constitutive exocytosis. The directly released content will be that constitutive exocytosis, and they are when packing and storing and processing will be happen, the stimulus is triggering them, they are called as non-constitutive exocytosis. So what are the 2 types of exocytosis? The movement of molecule from outside to inside, inside to outside, constitutive and non-constitutive. What happened in constitutive exocytosis? Is it movement of molecule through vesicles? No, they are the direct release. You have to memorize it. What are the 2 types of exocytosis and what is the difference in between the both the types of this exocytosis? You have to memorize it. And in next section we are going to discuss here membrane transport graph. This is the simple way of presentation of our what we discussed till now, how the working of the channels and the different types of carrier proteins. Here we can see the substances is required for the channels and carriers. What are their transportation mechanism is working here? They're following the saturation kinetics. Kinetics is basically, you know now, the transportation is stops at the certain time. Some molecules are gets transported, the substance from, suppose that this is the barrier, these molecules are transported inside the cell, these molecules are transported inside, but at the some time after, suppose that the molecules level will be increased, or the molecule amount will be increased, but the transportation carrier proteins are here through which these molecules are get transported. They are limited in number. Suppose that they are 50 and 50 molecules are coming and they are passing through it, but the molecules numbers will be increased, they are gets higher. Suppose that the molecules numbers will be containing like the 5000. This molecules number will be very high or the huge amount in number. They are going near for the cell for the passing from through it, but it can't travel all the molecules together. That's why they are getting build up there. These molecules are going to build up there and they're forming a certain type of saturation. Further time, after the some time, these molecules are going to be stop each other. How it happened? There's a special type of protein are regulating their activity, as we discussed previously. The special proteins are working in the channels and in the carrier proteins. Carrier proteins are basically called as facilitated diffusion. We already discussed in channels there is active proteins are working. We can see this graph. Here is the any concentration we taken and the transport, different types of transport is working. Suppose that in simple diffusion the concentration is increasing, the transport activity will be also increase. The concentration is, as the concentration increases, the transport is increases because it working on the higher concentration to lower concentration. Next point, suppose that facilitated diffusion. What happened in facilitated diffusion? There is a limited amount of carrier proteins are present in our cell membrane. And there is a limited amount of carrier proteins. It means the limited amount of molecules is passing through it. Suppose that initially the concentration will be 50 and the transportation will be 50 to 50, but after some times this concentration will be going to increase of the molecule. Suppose the molecule will be 500 and the channels will be same, they are the 50. There will be after some times some saturation is happen. There is some stoppage in their passing molecules, and this term is called as saturation kinetics. They are going to be stopped. These molecules are going to be transferred in a same amount, 50 to 50. Their molecules having no special carrier or no special carrier proteins are developed there to passing these molecules through it. So the saturation kinetics will be following. Same as the active transport. There is a limited amount of the active transporters are present in our membrane. So how many the active transporters are present in the membrane? That much energy or that much elements or the substances can passes through it. Suppose that these active transporters are 5000 in number. The 5000 molecules are passing at a time. Suppose that the molecules will be 5 lakh. Then it will be also passing the 5000 as same, but the number will be building up, they're increasing in high, but these molecules are going to be concentration will be somehow the concentration will be same. After the concentration will be same, the passing ratio of the concentration will be same, but the transportation charges will be also same. We can see like here, this is the graph of the transportation of the different types of molecules in this way. For this topic, the membrane transport, this is all about the membrane transport. In next topic we are going to the general physiology part 4. For now we are going to revise everything little about the active transport and the passive transport, the energy need or the no need of energy. And in the second point we can see about the what is talking about the vesicular transport. You have to memorize it. Exocytosis, you have to memorize it. These all are the important. What are the proteins involving in it and in which the energy is required or the energy is not required. What type of different transporters are working here, or the Barton protein. These are the things you have to memorize from this topic. And from my side, this is done by the vesicular transport or the all about the membrane transport in a summary way. You can read your books, everything from your helper, or you can also ask from me by the mail, or the everything is available on the YouTube or the Facebook or Instagram, everywhere. So you can go and check it and read everything what is delivering here. From my side, I am doing my best, and I want you do your best now, just now, not waste your time in these things to searching the videos and going anywhere, moving this way, not. Don't go anywhere, just stay to R.K Medicos. I will help you in every subject and all the topics we are covering here in YouTube. Don't worry about it. And when you want to a special help from any topics or any subject, then you can contact me. Everything is available, I think, on Facebook and Instagram. So all the best from my side. Take care.